Good morning, students. Good morning.
Good morning, ma'am.
So yesterday, I hope you have went through the titles and the meaning of those titles: network, activity, and event. We did three, right? What did I say? That in network analysis, you have to draw a lot of diagrams along with logical reasoning and sequential connection with mathematical calculation. Okay. What does that mean? You have to use your logic, then you have to use the perfect sequence of all the activities and events of their connection. Then you will have to also apply mathematical calculation. Then you will draw the network diagrams rather, right? And they are also known as arrow diagrams. So I told you that the arrows and the circles have got their names and we need to know their meaning, that which symbol signifies what. So already we did two things, that is activity and event. Those are the two most important things. Activity is the part of an overall project. It is a particular part for which lot of resources are used, time is consumed, and a purpose is achieved. So that is an activity, and activity is represented in the network by an arrow, right? And then we did event. You can also see circles on your screen. So those circles are nothing but the events. Now these events are only a particular point in time and then don't include any resources. They will not consume any resources. Event is only a particular point in time. Okay, so one activity will have two events. One is its starting time and is its ending time. The starting time is termed as the tail event. We also name it as ith event, and the end point is termed as the head event, and we also term it as jth event. Okay, so that's what we did yesterday. That was a recap. Today we will do merge and burst events. Okay, what does this mean? Now, so far you have seen a diagram where only one arrow is there. One arrow is having one starting time and one ending time. Now, for understanding merge and burst events, first you will have to understand one thing, that it is not necessary for an event to be the ending event of only one activity, as it can be the ending event of two or more than two activities. Such an event is called as a merge event. Now what will happen? Suppose a project is going on and three different activities are going on at the same time. Maybe one activity has started early and one activity has started late, but all of these three activities are going on at a point of time, and it has been observed that they will be accomplished or they will be finished at only at a same day. Okay, so three activities are going on, and you found after calculation that all these three activities will end in a single day. Then how will you draw the diagram of that? These three arrows, look at the first diagram, okay? These three arrows now, these three activities, these three arrows has been drawn to signify three activities that will end at a single event, at a single point in time, which has been represented by this circle. If this is happening, if after all the calculation you are at a point where you had to draw this type of diagram where three different activities are meeting at a single circle or single event, then this type of event is called merge event. Okay, if an event is a meeting point of more than one activity, It can be two or more than two also. Then that event is called a merge event. Okay. Then we come to burst event. Anyone's headphone is, the audio is turned on. Can you listen to a wind like sound? Anyway, anyway, so now let us look at the burst event. Now it is just the reverse case of the merge event. It is just the reverse case of the burst events. Merge event. Here the reverse thing will happen. If the event happens to be the beginning event of two or more activities, it is defined as a burst event. Now at a single day, suppose you are starting 4 different activities at a single day. So how will you draw that? You will have to draw one event and then you'll have to draw 4 activities starting from that event, right? So if this is the case, then it is called a burst event. Okay, it is called a burst event. So students, I'm having some problem in the headphone. I'll just log out and log in. Okay, just hold on, don't leave. I'll just log out and log in. Okay, I'm back. It's gone now. There was some network issue maybe. Okay, so have you understood merge and burst event? Just unmute and tell me, have you understood merge and burst event?
Yes, ma'am.
Okay, so let us move on to the next terminology. Next is preceding, succeeding, and concurrent activities. Now we come to the different types of activities. Okay, activities that must be accomplished before a given event can occur are termed as preceding activities. Now, suppose there are some conditions that you cannot start the painting of a machine before it's being primered with oil. Before it is being lubricated with oil, you cannot apply painting on that machine. So what will happen? This painting activity cannot occur before the lubricating activity, right? So that these activities that must be accomplished, this lubricating activity which has to be completed before a given event can occur. At this time, say painting machine will arrive after 15 days. So given event means that 15th day is the given event. So before the 15th comes, you have to accomplish the lubricating part. So this type of activities are called preceding activities. So the activities which has to be accomplished before a given event can occur will be termed as preceding activities. Then activities that cannot be accomplished until an event has occurred are termed as succeeding activities. Suppose it is a rule or it is a mandatory rule that after lubricating you have to give a time period of say 7 days. Say for example 7 days. You have to give time for it to soak. So what will happen? This activity of say painting cannot be accomplished until that 7th day has come, isn't it? So that 7th day, which is the event, has to occur before you apply the painting. So this type of activities are called succeeding activities. Are you understanding? Preceding means the first one, the first activity which has to occur before a given event, and succeeding is the activity which you won't be able to accomplish until and unless that time period or that event has occurred. That is called a succeeding activity. Now come to concurrent activity. Activities that can be accomplished concurrently, that is, activities taking place at the same time or in the same location, are known as concurrent activities. Now there will be situation when you won't be you won't have to wait for one activity to get accomplished. You have seen that in this project there are a lot of activities which can be accomplished at the same point of time, at the after the occurrence of the same event, same location you can use, same point of time also you can use. If this is the case that is happening in a project, then those activities which you can accomplish at the same point in time in the same given location, they are known as concurrent activities. Okay, understood? Preceding, succeeding and concurrent activities. The classification is relative, which means that one activity can be preceding to a certain event and the same activity can be succeeding to some other event, or it may be a concurrent event with one or more activities. Now these three terms which I have explained right now, they are all interrelated. They are relative to each other because obviously if you draw a diagram, you are drawing a network diagram, then you will the same activity which is a succeeding one can also be a preceding one, right? So when you will draw the diagram, you will have a clear picture of it. Anyways, I think it's easy to understand. Suppose you're drawing a network, you're connecting the activities with the event, then obviously it will happen that one activity will be a succeeding to one and the same activity will also be a preceding to one activity. And also that event only can be a concurrent to other activities as well. So these are the meaning of preceding, succeeding and concurrent activities. Then dummy activity. This is an important part, okay? This is an important thing. Dummy activity, see when you will draw the diagram, it will look something like this. You can see on your screen. The diagram will look something like this. Now, it may happen in some problem, you will not find a connection. You won't be able to draw an activity between two events. Then in that case, you will try out all means, but you will not be able to draw that activity connecting two different nodes or two different events. Then you have to understand that this is a case of dummy activity. In that case, you will have to draw a dotted arrow line and then join the two events which you are unable to match them. You will find that both the events are going to two different directions. You are completely unable to join them. In those cases, you have to understand this is a case of dummy activity. Certain activities, wait, someone is trying to join. Who is this? Kasak. Okay. So what is dummy activity? Certain activities which neither consume time nor resources but are used simply to represent a connection or a link between the events are known as dummies. Now you will not find any time or any resources being applied to that activity. It will be drawn simply to represent a connection or to connect the two events which you saw that both are going in two different directions and both are not connected at all. In those cases, you have to draw a dotted arrow line and show a dummy activity. The purpose of introducing dummy activity is to maintain uniqueness in the numbering system as every activity may have a distinct set of events by which the activity can be identified, and to maintain a proper logic in the network. So why we will draw this dummy activity? Because see, when you will start solving the sum, you will see that after drawing the network diagram, you are also supposed to name them. Say in this example, you can see it as A, B, C, D, like that, right? So like that, you have to number it. Then if it is not connected at all, then how you are going to number them? How you are going to name the activity? So in order to bring this distinctness, this dummy activity has to be drawn. Okay, once you find this type of scenario in a problem that two events you are unable to connect, there is no activity mentioned at all in the problem, then you will have to draw a dummy activity and join them. Then you mention dummy and name the other activities that A, B, C, D, like that. Understood? Is there any doubt? Is there any doubt till this much? We have done activity, we have done event, we have done two different types of events and three different types of activities, rather four, including the dummy. Is there any doubt till this one? This only, this much only terms you have to understand. Ask me if you have any doubt.
Ma'am, can you repeat the last one?
Dummy?
Yes, ma'am.
Okay, sure. See, whenever a problem will be solved to you, say you have been given a problem where the events are mentioned and the activities are also mentioned. Okay, then you will have to draw. Actually, it is not becoming so much clear because you have not done the sum. No, after doing the sum, it will be clearer. So suppose you are given with activities and there are time mentioned in those or in all those activities. Okay, then you will have to follow the question information and draw the network diagram. After drawing the network diagram, you may encounter a problem that from a particular event, two different activities are going in two different directions. Sometimes you may find a linkage. Say this in this example, you can see this activity B and C are starting from the event second event, right? And they both of them are going in two different directions. And this activity B has been headed towards activity D, but activity C is not heading towards anywhere. But you found that there has to be some linkage. There is a linkage between C and D. You have to create a linkage between C and D, but nothing is mentioned regarding the consumption of time and consumption of resources. But you found a linkage between C and D. So how will you link this to C and D? You cannot link, no? You cannot draw a line. There is no event after D. So, and also you cannot draw two same arrows also. That will be a mistake as per the information given in the question. So in this case, what you have to do is you have to link these two events which are going in two different directions by drawing a dummy activity. Okay. This type of activity will neither consume any time nor will consume any resources. This will be simply drawn in order to follow the number system. Okay. See, you found a linkage between C and D, but you could not link because no information is given. So you have to create this linkage by putting this dummy line, and then automatically this event is getting connected with the activity D. Okay. I can understand it won't be much clearer now because you have not drawn the sum. No, you don't know how to draw the diagram also. So you will have a blurred picture of this. So give me some time. Tomorrow only we will draw the diagram. After that it will be quite clear for you. Okay, Priyanka?
Okay, ma'am.
Yeah. Little bit of understanding is there, no, that this dummy will be drawn in order to create a linkage when no linkage will be given to you in the question. Okay, now some common errors. There can be questions from this part as well. Some common errors that you may draw while drawing the network diagram. First type of error is called looping. It is also called cycling. Okay. First type of error that can come in a network construction is known as looping. What is a looping? In a network diagram, a looping error is also known as a cycling error. Drawing an endless loop in a network is known as error of looping. Now you see in this example, see the diagram, follow the diagram, first diagram on your screen. This activity, see C, D and B. B, C and D. You see this in B you have the drawing shows arrows having two different heads. Arrows having heads on both the sides. Then C is following, this C is having one tail event and head event, no problem. D is also having one tail event and head event. But from this event, you can also reach to this event. I hope you can see my arrow. This event is also heading towards this previous event. At the same time, this first circle that you can see on your screen is also heading towards this event. So when you're putting heads in both the side of an arrow, that indicates a cycling error. Okay, this will not lead the project manager towards the completion of the project. The project manager will go on repeating the same activity and coming back to the same activity, same position, and he won't be able to progress also, because there is an error of cycling, there is an error of looping. Understood? So once you make this type of mistake, the project manager will not be able to proceed in this project. This is called a cycling error. Second type of error is called dangling. This is D, okay? This got missed in the picture. This is D. D for dangling. Second type of error is called dangling. What is dangling? To disconnect an activity before the completion of all the activities in a network diagram is known as dangling. To disconnect an activity before completion of all the activities in a network diagram. You see in the example, in the second diagram, you check. Now the first diagram on your screen, you check. This activity A has reached an end event. It has reached a head event, right? That means that activity has been completed. And then from this point in time, 3 activities have started, B, C and D, isn't it? From the first event, after completion of A, 3 different activities have started, B, C and D. Now B and C are heading towards the completion of other activities, but D has certainly finished. D has suddenly finished without the completion of other activities. B, C are still going on, but D has suddenly finished. This type of activity, this type of network diagram is called disconnecting one activity before the completion of all the other activities. And this error is called dangling. Okay. It may happen the picture is given to you in the question and you are asked to identify the error. So if you see this kind of mistake, that one activity has suddenly ended before the completion of all the other activities, then you will mention it as an error of dangling. Okay. And last error and last topic of this theory portion of this chapter is redundancy. This is called redundancy. There is an R here, okay? D in the second error, R in the third error. Please note it in your copy. It got missed while clicking the picture. So redundancy is the third error. If a dummy activity is the only activity emanating from an event and can be eliminated, it is known as redundancy. Now see, suppose you saw that one activity, here is a perfect loop which was going on. There is a perfect loop. Activity A and B has started together, and A has reached an event and B has also reached an event. And you saw that after completion of B, you had to start C from that point. And A and C are ending at the same point in time. After that, you could not find a linkage between this D and E activity and A and C activity. You could not find a linkage, but the project is going on. So you cannot draw a dummy in the middle or in between two events which doesn't have any other connection at all. Are you getting my point? Say this particular loop which has been created, not a loop, rather it would be wrong to say it as a loop. So this activity A and B has started together. Then while B got accomplished, C started. And A and C ended together. But after that, the information shows that a different set of activities D and E has started. But there is no information regarding A and C, what happened to A and C. So you had to create a dummy which as per your information regarding creation of dummy activity will be correct. But if this kind of network you are observing, look at the second diagram. If this kind of image is coming, that A, B, and C are creating a group activity, set of activity, and D, E, F, G are creating another group set of activity. But there is no linkage between A, C, and D, E. In those cases, it is called a redundancy error. It is called a redundancy error. Okay, so this keep in mind these three types of errors. Rest drawing of the network diagram, we'll do it tomorrow. We'll start tomorrow drawing the network diagram and solving the problems. It is an interesting chapter. It's a very, very interesting chapter. You have to draw the diagrams and then solve the sums. So, but there are a lot of chances of making errors. So you have to be careful while I'll explain the things. Okay. All right, then this much for today. Any question you want to ask? Any question till the time I'm taking attendance, you can ask. Okay. Do you have class now or directly at 8:40 now? You have a class now?
No, ma'am, 8:40.
Okay, so break me. Okay, please respond. Abhijit, Abhishna, Anurag, Aryan, Ashish,
ma'am.
Yes,
Yes,
ma'am.
ma'am.
Aryan.
Yes,
Aryan, Ashish present. Ashmita,
Ma'am, I'm
yeah.
also present.
Who is this?
Anurag.
Anurag.
Anurag, ma'am.
Okay. Ashmita, Bibechna, Debrupa, Harshita,
Present, ma'am.
Ishika Chaudhary,
Present, ma'am.
Ishika Agarwal, Kajal, Kasak,
Present, ma'am.
Khushi,
Present, ma'am.
Krisan, Mahima, Mamta, Mohit, Muskan, Prasad,
Yes, ma'am.
Muskan Gupta,
Yes, ma'am.
Namrata,
Yes, ma'am.
Nidhi, Nidhi absent today. Nitesh, Parnodeep, Pavan, Prashil, Pratiksha Chetri.
Present, ma'am.
Okay, Pratiksha Giri, Priyanka,
Present, ma'am.
Pooja, Rahul, Rajat, Ramkrishna, Rohit Bansal, Rohit Pandey, Sagar, Salina, Shalini, Shruti, Siddhant, Gaurav,
Present, ma'am.
Shobhit, Supriya, Suraj, Swayam,
Present, ma'am.
Tanya, Vinit. Okay. Kasak, you are not well today? Kasak, you are there? Nidhi is there. Okay. Okay, fine. That's what I was thinking. Where is Nidhi today? Given you, okay? Alright then, see you at 9:20 again. Bye-bye.